Welcome to this tutorial on debugging Rust in VSCode. If you're watching this video, chances are you're already familiar with Rust and VSCode, but struggling to debug your code effectively. Debugging can be a daunting task, especially when working with a systems programming language like Rust. But don't worry, we've got you covered. In this video, we'll walk you through the process of stepping into C source code when debugging Rust in VSCode. Rust is built on top of the LLVM compiler infrastructure, which allows it to generate efficient machine code. However, this also means that when something goes wrong, it can be challenging to debug. That's where this tutorial comes in. We'll show you how to navigate the C source code generated by Rust and understand what's happening under the hood. So, let's dive right in. To start debugging your Rust code, you'll need to set up your VSCode environment with the necessary extensions. You can find these extensions in the Extensions Marketplace. Just search for Rust and install the official Rust extension. Once you have the extension installed, create a new Rust project or open an existing one. Make sure you're running the latest version of Rust by checking the version number in your terminal. Now, let's say we have a simple Rust program that adds two numbers together. Rust and add x32, y32, e32, e32, uptune, funnel, olen pars, teddy, upportion, hopsumen, 1 volt, on the panel stand, object data, object was ready to fn main. Let result OK. 2, 3, 12. Print on result 1 bell. Out and say we can run this code using the cargo run command. But what if we want to step into the C source code generated by Rust? That's where things get interesting. When Rust compiles your code, it generates LLVM intermediate representation, which is then translated into machine code. However, there's an intermediate step, the generation of C-like pseudocode. This pseudocode is what allows us to step into the C source code. To enable this feature, we need to add a flag when compiling our Rust code. J-12. This flag tells Rust to include debugging symbols in the generated machine code. Once you've added the G flag, recompile your code using cargo build. Now open the debug panel in VSCode and click on the gear icon to configure your debugger. In the drop-down menu, select Rust as the debug configuration. With the debugger configured, set a breakpoint in your Rust code. For example, at the line where we call the add function. Then, start the debugging process by clicking the play button or pressing 5. As the debugger runs your code, it will stop at the breakpoint you set. Now open the call stack panel and take a look at the topmost frame. You should see something like Rust addad. Here's where things get interesting. If you click on the Rust addad frame, VSCode will show you the C-like pseudocode generated by Rust. This is what allows us to step into the C source code. As we explore the C pseudocode, notice how it's quite similar to our original Rust code. However, there are some differences. For example, Rust's ownership system and borrowing rules have been translated into raw pointers and references. Using this feature, you can now step through your Rust code line by line, examining the generated C source code as you go. This will help you understand exactly what's happening under the hood when your Rust code runs. To recap, here are the essential steps to follow. Install the official Rust extension in VSCode. Add the G flag when compiling your Rust code using cargo build. Configure the debugger by selecting Rust as the debug configuration. Set a breakpoint in your Rust code and start the debugging process. Examine the C-like pseudocode generated by Rust by clicking on the topmost frame in the call stack panel. That's it for this tutorial. We've walked you through the process of stepping into C source code when debugging Rust and VSCode. By following these steps, you'll be able to gain a deeper understanding of what's happening under the hood when your Rust code runs. If you have any questions or need further clarification on any of the topics covered, please leave a comment below. Don't forget to like this video and subscribe for more tutorials on programming and debugging. Happy coding!